Hello everybody, in today's video we're going to be continuing on from the definition of a derivative and going into actually finding certain types of derivatives. So first I want to say there are multiple rules for finding derivatives, and you may know some already, especially like the power rule. So let's just get into it. So first we have the power rule, which I just mentioned. So what is the power rule? So let's say we have a function that is x to some n, right? Well, the power rule is you just take the n down and then you subtract 1. So what does this lead to? Well, this would be n times x to the power of n minus 1. So this one's pretty simple, you can tell, because there's only one step that's involved and you can pretty much eyeball it. So let's say we have something like x cubed. What would the derivative be then? Well, using the power rule, we could take the 3 down and then subtract the 1 from the 3, and the exponent just becomes 2. So then what if you have something that's like 5x to the 4th? So what do you do now that there's a 5 there? Well, you can think of it like 5 times x to the 4th, and then you can just take the derivative with respect to x of this. So when you multiply by a constant, it doesn't do anything. So basically, what I'm trying to say is that you can take the 4 down still, so you get 5 times 4, and then you still have the times x to the n minus 1. And remember, n is 4, so we're going to get 4 minus 1, which is 3. So then we're going to get 20x cubed. And that's it for this rule. Now next is going to be the product rule. And this is when you multiply two derivatives together, or two functions together. So let's say you have some function x times x plus 1. Now you could distribute it, and that's a valid method too, but we're just using the product rule for this one. So what is the product rule? Well, say we have a function f of x and a function g of x. Then we have the derivative of f and the derivative of x. Well, let's say p of x is equal to f of x times g of x. So what is p prime equal to then? Well, the product rule will tell us that p prime is equal to f of x, just the normal function, times the derivative of g of x plus g of x times the derivative of f of x. So basically, since it's additive, you can do either one first, but the point is that it's one of the functions times the other function's derivative plus the other function times the other function's derivative. So it's going to be opposites. So each time there will be an opposite, right? Because you can see on the left side we have f and g, and then on the right side we also have g and f. So there's opposites, right? And just in each one there's going to be one derivative and one normal function, and the derivative is not going to be the same for either one. So knowing that, let's find the derivative of this here. Well, if we say the derivative of x is, well, first let's say this is 1, x to the power of 1. So let's take down the 1 times x to the 1 minus 1 is 0. Now we know anything raised to the 0 is 1, so the derivative of x would be 1. Now x plus 1, the derivative of this is a little more tricky, but still not very hard. So we know that the derivative of x is 1, so we can put 1 here. But then what's the derivative of 1? Well, when you differentiate a constant, or find the derivative of a constant, it's just going to be 0. There's no term, so it's just going to be 0. So it'll be 1. So both of these are 1, so you can kind of try to think of the product rule now. But let's do it here, okay? So let's say that the product is going to be g prime of x. So our first function, let's say that's x, times the derivative of the other one, which we found as 1 here. And then plus the second function, not the derivative, which is x plus 1, times the derivative of x, which is still 1. So what is the derivative for this then? We get x plus 1, which is just equal to 2x plus 1. Okay, so that wasn't too hard of an example. So now what if you have two functions that are in a quotient or dividing, right? So say we have f of x equals x squared plus 1 and g of x equals, let's say, x plus 3. Now, what if you have f of x over g of x? What do you do to find the derivative of this function? So let's say w of x equals this. So this is going to be called the quotient rule. So let me write this here. And the way that I like to think of this, and that many teachers teach it, is low d high minus high d low over low squared. So what does this mean? Well, you can imagine that low is the bottom of the function, the denominator, and that high is the numerator of the function. So then, knowing that, what do we immediately think about this? Well, we can then say that this is low times the derivative of high. So whatever d is in front of is what's going to be the derivative version of. So for example, we have d high here. This means we're going to be multiplying low times, and in our case, g of x is, or f of x is the high, so times f prime of x. And then for the other one, you can see that it would be high, which is f of x, times the derivative of low, which would be the derivative of g of x. So knowing that, let's go into our example here. Okay. So first, let's find this. Okay. What is f prime of x? And you can use the power rule for this. Now you take the 2 down from the exponent and subtract 1. So this is just going to be 2x, given that the derivative of a constant is 0. So what is g prime of x? Well, we said that the derivative of x is just 1. So knowing that, how can we use this to find the derivative? Well, let's say that w prime of x equals low, which is x plus 3, times the derivative of high, which we found is 2x. So let me use red for that. Minus high, which is our x squared plus 1, times the derivative of our low, which we found is 1. And then this is going to be over low squared. And keep in mind that low is g of x. So we just have x plus 3 squared. So you can expand that if you want, but that is the correct answer. And by expand, I mean you can like multiply this out. I think most of the time you don't have to expand this, especially for the AP tests. But if you want to multiply those out, maybe to get like 2x squared here and then minus this x squared, that's probably what you should do. but that is the answer here. So next, we're going to be exploring the chain rule. Now, the chain rule is probably the most important rule to know. They're all useful, but chain rule is very important. So what if you have a function that is like, say, g of x equals 3x plus 1, and then that's all squared. Well, what do? I guess you could say, for example, that you could set a function like, so in this situation, there's kind of like two functions here. So we can say really that u is our 3x plus 1, and then that there's an outer function that is giving us like u squared. So how do you find this then? Well, you take the derivative of the outer function with respect to u. So let's say y equals like our u squared, right? So if we take the derivative with respect to u, we bring this down. So think of it like this. Think of y as u squared. So you bring the power down, and then you keep the u, and then you do 2 minus 1, which is just 1. So that's part of the derivative of this. Now, so we have 2u, and then you have to times it by the derivative of the inner function. The inner function is our u, so you have to times this by u prime. So what does this result in? Well, this results in 2 times our u, which is 3x plus 1, and then times u prime. Well, the derivative of a constant is 0, and the derivative of x is just 1, so 1 times 3. So times 3, which will be 6 times 3x plus 1. And a way you can think of it is if you have a function u, and then y is the outer function, you can think of it like dy over du times du over dx. So this is just the derivative of the outer function, our 2u here, and this is just our 3, or the derivative of u. So it's sort of like the derivative of the outer with respect to the inner, because y is our outer function with respect to u, which is our inner function, times the derivative of the inner, the derivative of u, with respect to its variable, which is x. So let's do one more example of this chain rule. So say we have something like, I don't know, 5x plus 10 cubed. Well, what do we do then? We'll first identify the inner function. So let's say our u is the inner function, which is 5x plus 10. And then identify the outer function will be u cubed. So keep in mind dy over du times du over dx. Well, dy over du is going to be 3u squared, and then du over dx is just going to be 5. So we get 15u squared, which is going to be 15 times 5x plus 10 squared. So pretty simple once you know that. So now let's talk about trig derivatives. So I'm just going to go over this pretty fast, but they are very important to memorize. You have to memorize these. So we have sine of x. So let's say, well, I guess let me write it like this. So d over dx of sine of x. What do you think this equals? Well, if you look at the graph and you analyze the slopes of the graph, then you can see that this is just going to be cosine of x. So then what do you think the derivative of cosine of x is? Now you might be saying sine of x, But that's not true, and it's close. But actually, the derivative of cosine of x is negative sine of x. So keep that in mind, and that's very important to have memorized. If there's anything you need to have memorized, that's very important. Now let's scroll down here and say d over dx of tangent of x. What does this equal? Well, this is equal to secant squared of x. And you can actually find this, once you know these two up here, you can find this using the quotient rule. Because remember, tangent is just sine over cosine. So you can use the quotient rule with those to figure it out. So then what do you think the derivative of cotangent is going to be? Well, the derivative of cotangent is going to be negative cosecant squared. So you can tell that cosine, cotangent, negative, tangent, sine, positive, right? So that's very good to know, crucial. And then we just have a couple more here then. Now, d over dx of secant of x. What do we think this is? Now you can use quotient rule with this one because it is well, basically what it is cosine in the denominator, right? So you can use quotient rule to figure this out too. So we would basically, you just get secant x tangent x. And then knowing what we know already about the negatives, what do we think the derivative of cosecant of x is? Well, let's say negative cosecant x, cotangent x. So yeah, you can take a screenshot of that, but there's much better charts online. This is terrible handwriting. If you want to take pictures of those too, but this is very useful. Now, there's like only a couple more things I want to cover. The derivative of e to the x. This one you may know, it's very popular. But the derivative of e to the x is just itself. So d dx of e to the x equals e to the x. Yes, it's just that simple, okay? Now, if you have e to the 3x, what's the derivative of this? Well, remember chain rule. Let's set u equal to 3x and y equals e to the u. Well, you would get the derivative of the outer, which it would just be e to the u, because that's still just e to the power of something, times the derivative of the inner, which is 3. So you would get 3e to the 3x. Just important to keep in mind. Now, what is the derivative of the natural log of x? This one is also pretty popular, so you may already know this, but d or dx of ln of x is just 1 over x. Now, say for example, we have something like ln of 5x plus 3. What's the derivative of this? Well, using the chain rule by now, we can get that it is 1 over 5x plus 3 times 5, which is 5 over 5x plus 3. Now, something that I think is personally important to know is that if you have something like ln to the 3x, you may think that it's going to be something different, but if you do 1 over 3x times 3, which is how you would find this derivative, the 3's would cancel out, and so you just get 1 over x, which is the same as this. So if you find ln of just a constant times of the variable, and the variable is not like squared or anything, then it'll likely just be 1 over x. So one last one that I want to talk about, and that is going to be something like a to the power of x. So this one you kind of just have to memorize. Now, unlike the e, it's not going to just be a to the power of x. So what instead you'll get is the ln of a times a to the power of x. And the reason for this, or I guess you could say the reason why when using e to the x this doesn't show up, is because the ln of e is just 1. So this doesn't show up. So it's just e to the x. And that's really the last rule I have here. I know that I busted through a couple of those very fast, but this video is getting kind of long. So thank you guys for watching, and have a good day.